Hello and welcome to, or welcome back to, the channel about the Nasdaq scalping bot. You're looking at the second part of a two-part video about implementing AI into your project, or as I do it in my project, but giving you the tips and advice how you can do it in your project. And by watching this part of the video too, I'm planning, and that's what the whole idea was behind the video, I will show you what I did and which mistakes I did and how you can use it for yourself without using that much time. So it's time saving to watch the video instead of doing it all by yourself with ChatGPT, and only deviate when it's absolutely necessary for your own project. So this is part 2. I hope you'll like it too. Well, let's go back to the training. So these are the shapes. I'm going to disable this one too. Then the X-train flat was flattened the 3D time series into 2D. Also, my attempt to create a higher accuracy because I was only at 34. So these are all things I did to get a better accuracy, and flatten 3D time series into 2D instead of 3D should be better. Train flat, it's a possibility. I don't know if I need it. And then smoothing was, I didn't explain it, but I disabled it for now. Smoothing is when you're gonna have a more balanced set of your training data, because I had a lot of zeros of holes, a lot of zeros in my training data, and not as much ones and twos. The answer of the AI on my question was always hold. And to smooth those out, there were added some artificial ones and twos to smooth out the total balance, to balance the total numbers of zeros, ones, and twos. That's what smooth does. And I will not do it right now. I just want to take a look at this. This is the model training as it is. I use a training depth of 256. And I started with, I believe, 128. The larger this number is, the more intensive it uses your CPU to do the calculations, but the better the results will be. And I'm going to take a look at the ChatGPT of last week, in which I started with. So be with me. I'll be back with you in a second. This is the original one, and you can see I started with the original model sequencing as an LSTM of 64 with a back training of an LSTM of 32. That's what I started with. It's an original version of the AI training model. The sequential, as in this is the actual training of your model. And I started with 64 and 32, and I ended now with 256 and 128, all in getting a better result, a higher accuracy than the ones I had. So for now, I'm going to change this one back to the original 64 and 32. And I go down then you see I had commented out a dense, and dense is if you want to use only one answer, you expect one possible answer from the AI, and I expect, because I have 3 classes to expect, it could be a buy, a hold, or sell, I use a dense of a unit of 3. And with a soft max was advised to me by ChatGPT, and the 10A was the one you should use when you have only one classification of the response you expected from your AI. Then I have some other stuff right here also commented out, because I did comment them out especially for this video to explain to you guys the differences, so you don't need to go through hours with ChatGPT to find out that you should only change optimizer Adam with a focal loss to the cross and trophy. These are all different model compilers you can use to train your model. And I started original with this one, the model compile optimizer is Adam, with a loss of a focal loss. Don't ask me what it is, but an alpha of 24 and a gamma of 2 and a matrix is accuracy we want to know. That's what I started with. And I also use this one with a loss of MSE with a matrix accuracy, also for a class 1 classification. That's what we talked about a few minutes ago. If you only have one class, then this model is the best to train with. But I ended up with the model Adam, and then the loss as a spear, categorical, cross and trophy, with the matrix as an accuracy. That's the one I ended up to use. So there are 3 models within the model you can use, and you can test with these 3 and find out which one of those 3 give the best result. Then there is something like a class weight, and giving weight to a specific class is what it does. And there are several variants you can use, and this one was also the class weight dict. Tune class weight of the model. And I already explained to you several times in this video, I had too many holds, and this was also an advice from ChatGPT to give certain weights to specific values that the AI should or should not return. And as you can see right here, you can do manually, and I did with a half for a hold and 2.2 for a buy and a 1.6 for a sell. That was what I did manually, but you can also do this automatically, and then you use tune class weight with the model. That's a possibility. You can do it this way. Then there's also an automatically version. Then the class weight will be balanced based on your training data, and then it creates a new data. That's when you want to do it automatically too. And you can do it manually to put in a hold, a buy, or a sell by giving them manually a weight. And I did with half, 2.2, and 1.6. And then you ask me, how do you know what the best combi was? Well, we skipped it on a few minutes ago in this part of the code, this function, and I will reactivate it. and give you guys the chance to see it and stop the video and code it into. Wait. As I explain it, what I did was creating the training set and getting the set as it were training sequences. So the start of the bot training, then I give up a hold start, a hold end, and a hold step, and a buy start, buy end, and a buy step, and a sell start, sell end, and sell step. And then I made it a while loop with what will be the best values, and this is Dutch, new values should it be. And it took a while, because what it does, it goes through each possible combination of the values between 0.5 and 1.0 with a step of 1 for the hold, the buy, and the sell. It will go through each of these steps, and then when it sees that the best value is there, it will keep score of which combination of those values are the best combination to use in the training of your AI. That cost me several hours last weekend to go through this, and I ended it with steps of 0.1. But if you want to, you can, if you have the time for it, you can go to steps like this. And then you know, if you have to go from half to 1 by 1/10,000th of a step, something like this. And then also for this one, yeah, you can go to bed. You put it on, you say, see you in the morning, because this will take 7, 8, maybe 10 hours to go through each step. But it is possible. But then you get the best combination you can put on your class weight like this. So I did this manually, and I'm gonna disable this one too, because I want to do it. I want to train the bot and see how it reacts with all those extras I did last weekend. And so I want to keep it as clean as possible. This I will keep a couple of seconds, so if you need it, press pause, and then you can code it into your own coding. But I'm gonna disable this one too. Yeah, so go this, pause, then you have all of this, and then you pause again for this, and then we can go on down, and well, wait, let's pause at this point. So you have this coding too, including the smooth. And then we go to the modeling, how the sequencing should be used. We are using 64 and 32 right now as the sequential that should have been used, and the sequence length you see right here is 10. I created a general code, a global variable for it at the begin, and so if you don't, the sequence length I'm using is 10. Then with this, the basic of how the model should be trained. Then this is the actual training of the model. Model compile, the word says already, compile the model. Then there is the class weight. I disabled that one too, because it's only added while I didn't have the expected accuracy I wanted to. And then the fit, as in how much does it actually do, training, and I set the epochs as the reputation, how much time I will bring it back to 50 to the original 50 with a batch size of 32, and then we have the testing. Then I will activate the print to see the test loss. Then the predictions will be calculated. That's the actual testing of your testing data versus your training data. How good are the predictions? And then I'm going to print the predictions, and I'm going to print the true labels. This prediction first 15 as what did the bot predict, not the bot, what did the AI predict? And the next line, the true labels, is from the testing set. You see, that's what it actually should have been. And I'm going to bring this one back to 5 and not 15. Again, last week I tried a lot. So predictions, the first 5, and now the testing 5, as in how many labels were actually correct with the AI. Then the precision score is calculated, and I want to see those two. How are we? The F1 score and the recall score, that's been produced by a coinference confusion matrix. And by presenting the confusion matrix to ChatGPT, he gave me some advice, and I will explain to you what the confusion matrix does, because I already know now what it does. It comes in handy to explain to you guys. And then we print all of that. We print the precision, the recall, the F1 score, Formula 1. Yeah, Max Verstappen. We won again. And the confusion matrix will also be printed. Then the unique, I will do not, because that is how many unique labels were there. That's what I needed for the smoothing. So I disable those, but you can count the number of unique labels and print this, so you see if you have an imbalance in your training data, in your historical data of your training data, and then it will be saved into the models. And then I see we have the KNN model training, and I will disable the KNN model training for now. So we're only going to do the RNN model training. And right here, you see last week results as of the training. The precision of the last week training first time was 15%. With a recall of 39 and an F1 score of 22 with the confusion matrix. I want to explain that one too. And the KNN accuracy was 97%. Very high, but not that reliable on that. This was actually high, because KNN, the nearest neighbor function, yeah, you can use it, but it's not. But we're going to use them anyway. But for now, we start with the RNN model, and I want to see how we do now. And we go through the epoch of 75. And let's start the bot, and I will back with you if we have the results. And there we have the results. We have an epoch of 50-50. I show you what's happened. So while training your model, you see what he's doing. And this time he's training the model 50 times with the data and see what the accuracy is and how much loss and which values it uses, etc. So this is for 50 times. You're going to see this. If you don't see this, you're not training your model. So that's your epoch. You have to see this. And then we're going down, and then we have the accuracy. And the predictions were the first 5 predictions were 5 zeros, and the true labels were 5 zeros too. And the RNN position is now at 56% with a recall of 75. I don't know what recall means, but an F1 score of 64. Well, let's put this into the ChatGPT, and maybe he can tell us what this means exactly. But I'm already suspicious because 5 zeros with a response of 5 zeros. Yeah, 0 has the most prominent value in the set, so that there is a 5 zeros with a response of 5 zeros. It's not good enough for me. But let's put this into ChatGPT and see how he reacts to this. Well, if you look at what the results are with ChatGPT, he comes to the same conclusion as that I did, and well, it's predicting the class hold, and with only 5 labels to go, it's, yeah, logical that you always see 5 zeros and that the labels are 5 times 0, 2. And with a precision of 65%, predictions only were 65.25 were correct. Although all 5 predictions were correct, we still had only a 65%. So it means there was something wrong too. With a recall of 0.75, correctly identified 75%, that's rather high, and then the F1 score of 64 represents the balance between precision and recall, but since the model predicts only hold, the score is misleading for buy and sell. And then the confusion matrix, that's what we're talking about. You see, there were 114 holds predicted as a hold, and 12 times a buy misclassified as a hold, and 26 through sells were misclassified as a hold. So again, the same problem I had last week was that there are too many holds in my data that actually gives a good representation of the score. And although the precision is now up to 56%, better than last time, it's still not good enough. So going back to the code, and then I'm gonna adjust again, like I did last week, slowly the values to get a better precision. And I'm going to start with reactivating the smooth. Where is the smooth? I'm going to reactivate the smooth, and I print the, oh yeah, there it is. So I can show you the difference between those two, the before smooth and the after smooth, how the training data looks. And I'm going to restart, and then we're going to see what the difference was or is between those. And I'm going to take a copy of the first results and put them down there. And then I'm going to restart the bot and see how his accuracy is now with the new smooth in it. Those reds you will see too, like this one. These are warnings, and these are not arrows. So I asked ChatGPT, oh, I read, no, those were not arrows. They were warnings, and you don't need to do anything with it. It's just a warning. Now we activated smooth, and I first want to show you the smooth, what it does. Then I need to go up to the smooth section. Before the smooth, the count was 464 0.0s, as in holds, and 81 of the number 2 sell, and 97 of the number 2 of the number 1 buy. That was before the smooth. After the smooth, we have the 0 is 446. We also have 446 ones and 446 twos in the model training data. And if we're going to look if that would help, then we're going to look at the results. Then we see that the results are now 56%, and we had 56.25, and now it's exactly the same, 56.25, with a recall of 75, and the F1 score is 64, exactly the same. So this could not be accurate, because we have exactly the same numbers after I activated smooth. So there's something wrong with the smooth data, and then we have to go back to the smooth. Where is smooth? There is smooth. And I have to take a look why it does not improve. And I did a lot of experimenting last weekend, and so excuse me, but I'm preventing that you guys go through all this experimenting and lose lots of time, but just experimenting. And so I'll be back and show you what's different in actual doing this, and I think I already see it even before we go out, because I see reshape back into original 3D shape with a sequence length, etc., and there's a flatten. So to use smooth, we need to flatten the training, the X-train, because I see that X-train flat. There's no X-train flat. So did I? I did delete. So we have the X-train flat using here, comes up with a train's balance, and then I see reshape back into the original 3D shape. So these are all necessary to build a smooth environment. Okay. So you all need this to get your smooth going on. Flatten from 3D into 2D, then smooth everything out, and then retrain and reshape from 2D to the 3D shape. And then we have the X and Y train again, and we're gonna run again and see if the precision is better now after we added this smooth. Oh boy, with the smooth now fully activated, we are at a precision, RNN precision of 0.029 almost 3%. So that's not it. We're going to disable the smooth, and let's get back to the original we had as in 56%, and then see what we can do more. This entire section, disable. Let's restart again and see if we get back to the 52 we had, 56. So we're back up to 56, and I disabled the smooth, and I'm not going up to the measurement I did last weekend. Also is reactivating the counting of the zeros, the holds, and then physically delete from the training data, from the historical data, 19 out of 20 holds, so that the number of holds are down. We had 464 items of holds and only 19 of the other stuff. So do I have the results? No, I don't have results anymore. So we're going to delete a significantly large number of holds in the historical data, and then see what this does to the results of the bot, of the AI, after 50 trainings. And then we are down to 26. That's not good. So 1 out of every 4 is correct. I'm going to stop this one, and I want to see if I'm going to change the testing to 15 numbers like I did last week. 15, 15, 15, 15. Rather. That won't change the precision of the AI, but I just want to see how much 15 tests would do, how often the test would result in a buy or a sell. Now we have 15 times a 2. So now as the 2 is overrepresented in comparison with the zeros and ones, that's not that bad. But our precision is down to 26. That has no use. Let's bring back the 19 less drastically to 9 out of 10 instead of 19 out of 20, because I have now too many 2s and no zeros at all. Run again, and that's all you're going to do. If you want to have your AI to be perfectly, you have to test and to see which is the perfect balance between your training data and your results. That's the most time costly part of your AI adding to your project. It's not the coding. The coding we did in what, half an hour, 3/4 of an hour, but the real testing and fine-tuning, that's take a lot of time in your work of this. And we have down it to 0. The holes are only 1 out of 10, and still the predictions are almost only 2s, and the precision is still at 1/4. So deleting all the zeros is not the answer. Let's try once more with 5. and see what this results into. And I know I want to show you the results and prevent you from all those hours of testing and checking, but I only show you this, like what could you do to get a better result of your RNN. And I see that we are now at 23 with a recall of 48 and F1 score of 31 with a confusion matrix that is not better, 9, 17, and 24. So deleting some of the holes in the data has not the effect that it had last week, and it's even worse, which means that the historical data I created this week is better than the historical data of last week. So because last week I actually needed to delete 19 out of 20 holes to even get to a percentage of 30%. And now, if I don't do anything, we are getting to 56%. Now, we're back up with only the zeros in the 15 and some ones and twos in the testing, but the RNN precision is 56. So, and the F1 score, it has doubled to 64. And 114 zeros, 12 ones, and 26 twos. Yeah, we're getting better, but it's exactly the same as that we had when we started with all of this. And I'm now going to add the weight. What class weight does is give a weight to each value in your training data, and as in a buy and a sell, the buy should get a higher value than a hold, and a sell should always get a higher value than the buy, than the hold, but a lower value than the buy. So let's see if the automated version does what it should be. Let it run. And if this does not work, oh, we get an error. Why do we get an error? Okay, we corrected the error. And all I had to do is the class weight dict after I have decorated what it should be. And I run the program, and now I see that the prediction, the first 15 are all zeros, and there should be some 1 or 2s in between, and the RNN position is right back as what it was, 56.25, with a recall of 75 and F1 of 64. So we don't make any progress right now with this AI training in this way. So I'm gonna do one more thing, and that is I'm gonna try two things. But first I'm gonna try to add my own class weight, and then I'm gonna need to move this one. And disable this one. That's what I'm gonna try first. And if this doesn't help, then I'm gonna end up the original model, what we down from 256 to 64, but to give more space to the model to play with, and the epochs, the training of, are gonna add up to to 75, I would say. But the prediction now with the class weight prediction of this, what you see, now we have a prediction, we have a precision of 0.02, only 2%. So this doesn't help either. And, oh, wait. Class weight, yeah. This doesn't help either, so I'm going to disable this one too. Disable is not delete. This one and at this point too. So the class weight, I'm going to remove it and up with the model back to, let's say we start with 128 and 64. Doubling it. See what this results does. Because 0.02% is not good at all. And I suspect that the training data, although we are in the 300 or 400 rows, is still not big enough to get a good precision. Yes. We are with an RNN precision up to 56.25, and this is exactly the same after I amped up the LSTMs, and I'm going to end up once more to 256 and 128. And now we have again 56, 75 with 64 matrix. It does not change, even if the LSTM is higher. It does not change the results. Although the results are better than last week. Last week we had a result of 56, of 31, 32. We now have a result of 56. But the add-ons, the fine-tuning of the AI, what I did last week, are now only making it worse instead of better. So I don't gonna do that one. And maybe after the video, I'm gonna reuse this procedure to test the different class weights, but I know it's gonna take some time to walk through all these values. So I'm not going to tape that on video. But I fear that even if I do that, and like I just said, that with this manual weight action on each class does not have any effect. So let's go to and activate the KNN, the KNN model. And the KNN model works on the same model, or the same training data as the original RNN model. So I don't need to change anything on this one. Where is the model? This is the model. This is, I believe, to make it visible how the model does. I believe, because it's pit plot, and the PLT plot means we're plotting something. Let's activate this one. And then run the show again. And then see how good the KNN is versus the RNN. And the KNN was last week very high, 75, and while the RNN was only 33, I didn't have that much trust in the results of the KNN as being with 75% precision a very good and reliable outcome. So if both of them are there we have, oh, you guys don't see this. Let's make me this visible for you. So I made it visible for you. This is the KNN plot, and it shows you at what point the best accuracy is at this moment, and the KNN has a rather high accuracy when the number of neighbors are around, this is the highest point I can see, this should be 9-ish, like this. Yeah, this is 2.5, so this is 9-ish. Okay, let's close this. So if the number of neighbors K is 9, oh, did he print the optimal K code? Yeah, optimal K is 9. He did print the optimal K code, but you saw in the plot that it was so. So I'm gonna comment this one, and if you are coding along, you already have in the pause get this print code to get your K9, and then the optimal should be K9, and the K9 accuracy was with a K of 1, because we had a K1 originally, but now we had 74 like it was last week, and I want to see if I'm going to run this once more, what the K with a K of 9, how the accuracy is for then, for the K9. It's not for RNN, repeat it, but know your neighbor. Know your nearest neighbor network. Well, the RNN precision is 0.56, is better than last week, and the accuracy is now at 77. That's 2% better than last week. And I keep it here for now for the video, because you have seen now all the tips and tricks I have in-house to build a AI into your project. So I hope this video was helpful to you, at least in time, because I bring back the time that I spend in, and we're talking about almost 32 hours of work, my work, bring back to whatever the length of this video gonna be. I don't know, something in an hour or 2 hours. No, not 2 hours, but something in an hour. So you have already saved time by watching this video and coding along, and now you're gonna have to spend some extra time to find the right precision for your own project. And if you find a better way, now let me know. And if you think this video was helpful for your project, please leave a like and subscribe to the channel, of course. And if you want to know how I'm doing further with this project, and how my bot is doing, and how the AI is affecting the bot, and how I gonna make profits, then stay with the channel, watch some other videos. I do a daily report of how the bot is doing. And I also have a Twitch channel of which I show the performances of the bot each day, each working day. And I will leave a link in the description. And I have a Discord channel too, where I show and discuss everything about the bot and the market. And you are welcome to join the Discord community, of course. And then you can leave, if you find a better way than mine, then go to the Discord and tell me, John, your code sucks. My code is better. Please use this for your bot, for your AI, and I will thank you for it. So for now, have fun.